last video we had discussion about Rutherford model of an atom and Thomson model of atom. ठीक है, we had the Rutherford model, their observation, conclusion, postulates. Let us saw the drawback of the Rutherford. ठीक है, according to Rutherford, electrons are revolving around the nucleus. Electrons are revolving around the nucleus. ठीक है, in a path. Okay, when anything is in a circular motion, observe here, this is nucleus. According to Rutherford, electrons are revolving in circular motion like this in a path. Okay, when electrons are revolving, since it is a mass, when they are revolving, there is anything which is in circular motion, the chance is there they will accelerate and move away from the atom. ठीक है, okay, when electrons moves away from the atom will not exist. ठीक है, no electron means no atom at all. So this is the drawback of the Rutherford. Here the revolution of the electron in a circular orbit is not accepted to be stable. Okay, any particle in a circular orbit would undergo acceleration. When they accelerate, what the chances are there? The electrons move away from that circular path and move away from the atom. When there no electron means no atom at all, which is quite not possible. ठीक है, when electrons are not there, no atom in the sense no matter at all, which is quite not possible. This is the one of the drawback. This drawback is overcome by a new chemist, name is Niel Bhor. He given the postulates of this model of an atom. According to him, only certain special orbit known as discrete orbit of an electrons are allowed inside the atom. According to this Bohr is telling that electrons are not revolving only in a path. They are in a specific path. That path are nothing but orbits. That orbits are nothing but energy levels. In the second point they are telling, while revolving in discrete orbit, the electron do not radiate energy. Okay, that electron path is there, no? That electron path is not only a path, it is a energy levels. In the energy levels, electrons are revolving. These energy levels not leaving the electrons or from the atom. They will not radiate outside. They will not radiate outside. Okay, or they will not radiate any energy outside when they are revolving. So in this way, the drawbacks can be overcome by the Niel Bohr. Okay, by given this two postulates. What are the two postulates of the Bohr's model? Only certain special orbit known as discrete orbit of an electrons are allowed inside the atom. So these are the orbits here. Means specific energy levels of a fixed electrons. Okay, in the first specific level or energy level, or we say orbits, only 2 electrons are allowed. In the second orbit, 8 electrons. In the next orbit, the energy level or the orbit, again 8 electrons. Okay, so depends upon the number of electrons present in the atom. The electrons are distributed in an atom in a specific energy levels. Okay, when they are revolving, they will not radiate out their energy. Okay, this is the model of an atom. They given the names for this orbits. Okay, like here, K shell, L shell, M shell, N shell. Okay, this is nucleus. Okay, here nucleus at the center, first orbit, second orbit, third orbit, fourth orbit. Names are K, L, M, N. Okay. Okay, K shell having 2 electron, L shell having 8 electron, M shell having different number of electron. How to find which orbit having how many electrons, or how to find the distribution of electron in a specific energy levels. Okay. He Bohr given a formula. That formula is 2n square. Okay. N is a number of shells. Okay. Suppose in first shell want to find how many electrons are there, then we need to put n value how much, equal to 1. Okay. In this formula what will get? 1 square. Okay, so how much? 2 means in the first shell or K shell, how many electrons? 2 electrons are revolving. ठीक है. Similarly we can find the second shell by putting the second shell number 2 square, how much? 2 into 4, how much? 8 electrons. So in the L shell, how many electrons are revolving? 8 electrons. Similarly we can find in the third shell. ठीक है. 2 into 3 3 is 9, how many electrons? 18 electrons in the next shell, that is M shell. Similarly we can find like this in the fourth shell, how many electron revolving? 4 square in the sense 16. ठीक है. 16 to the 32 electrons are revolving in the N shell. ठीक है. So in this manner we can distribute the electrons here, K, L, M, N, O, P, like that. First shell, second shell, third shell, fourth shell, by using formula 2n square. N is what? Number of orbits. 1 orbit, 2 orbit, 3 orbit, 4 orbit. By putting this n value in 2n square formula, we can find number of electrons in that orbit. Okay. Next, about the neutron. We had about discussion about the neutron. Who discovered the neutron? J. Chadwick. Okay. Is there mass for neutron? Yes, of course. Where they are present? Electron present at the center of the nucleus. Okay. And what is the neutral? Whether the neutron having any charge? No, neutron doesn't having any charge. They are neutral. Okay. Okay. Now, yes, we have this heading also. How are electrons distributed in different orbit? Depends upon the formula. 2n square formula. 2n square. Okay. N gives number of shell. First shell, how many electrons? 2 electrons. Second shell, 8 electron. Third shell, 18. Fourth shell, 32, like that. Okay. Now depends upon this electron distribution, we can draw dot structure also, which given here. Okay. Hydrogen having 1 electron only. Hydrogen atom having 1 electron only. Okay. Therefore you can show the dot structure of hydrogen. This is the nucleus. How many electrons? 1 electron only. This is hydrogen. Helium. What is the helium? How many electrons? Helium having 2 electrons. Where they are present? In the first shell. Okay. 1 electron, another electron. This is a nucleus. Okay. This is a helium atom. Next. Similarly, we can have all the elements, atoms, electron distribution. Carbon having 6 electrons. Where the 6 electrons are present? Around the nucleus in a specific orbit. First orbit, how many electrons? 2 electrons. Second orbit, how many electrons? 8 electron maximum capacity, but here already we had 2 electrons. Remaining how many? 4 electrons are here. 1, 2, 3, 4. Total electron 4 plus 2, 6 electrons. Okay. This is the distribution of electron for this elements. Okay. Sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, argon, neon, helium, fluorine, oxygen, nitrogen, carbon, boron, beryllium, lithium, hydrogen. Okay, these are what a distribution of electron in an atom and dot structure of a atom of a specific elements. Okay.